Everyone, I am Dhruti from Sri Venkateswara College of Engineering, CSEI Department, Bengaluru. Today, I will give a small presentation on genetic algorithm. Let's move to the introduction of genetic algorithm. Introduction. Genetic algorithm is a search-based optimization technique based on a principle of genetics and natural selection. It is frequently used in find optimal or near optimal solution to difficult problems which are otherwise would take a lifetime to solve. Nature has always been a great source of inspiration to all mankind. Genetic algorithms are such based algorithms based on concept of natural selection and genetics. Genetic algorithms are based on the principles of selection, crossover, and mutation. So here it mainly tells that it is related to the nature, how the nature works. In the same way, we can use it and we can solve major problems. We can easily find the optimal solutions or nearly optimal solution by using these genetic algorithms. Otherwise, it would take a really long time. And we can take this as an inspiration and it can be used. It will relate to the concept of natural selection and genetics. And the main basic or the foundation principles which involves in genetic algorithms are selection, crossover, and mutation. Population. It is a subset of all possible solutions to a driven problem. Chromosome. It is a chromosome is one of the solution to a given problem next. Gene. It is one of the element position of a particular chromosome. So the basic terminologies which involves here are the population, chromosome, and the gene. Population, we can tell we have n number of solutions, among them a set or it is not a set, it will be a subset of among them in order to solve a problem. And chromosome, and every chromosome is solution for a given problem. And gene, so it is a position of that particular chromosome. Then this is the diagram which we can see. Population initialization, fitness function calculation, crossover, mutation, survivor selection, terminate, and return best. And in the survivor selection, if it is not meeting the requirement, and you're going to terminate, and you're going to again go from the fitness function calculation, crossover, mutation, and again you're going to check it. Then if it is fine, then you're going to terminate and you're going to give the best among them. Population initialization. The genetic algorithm starts by creating an initial population of potential solution. Each solution is represented as a chromosome, typically encoded as a string of binary digits. The population size and chromosome representation are critical parameters in genetic algorithm design. So it mainly starts with the population initialization. We create an initial population and they are nothing but the solutions. And every solution will be represented as a chromosome and it will be encoded or it will be written as a string of binary digits, 0 and 1s. And the population size and chromosome representation are very important in the algorithm design. Fitness evaluation. Fitness function evaluates how well each solution performs in solving the problem. Solutions with higher fitness values are more likely to be selected for reproduction. The fitness function guides the genetic algorithm towards finding the optimal solutions. So here mainly we have the initial population and we are going to check which among the population solutions are really good. So in order to check or in order to verify, we have a criteria called as fitness. So if the fitness evaluation means if it is reached, then only those individuals will be taken for the further reproduction process. So this is about the fitness evaluation. So population, evaluation, selection, crossover, and mutation. Then we move to the selection. In the selection phase, individuals from the population are chosen for reproduction based on their fitness. Solutions with higher fitness values have a higher probability of being selected. Different selection strategies such as roulette wheel selection and tournament selection can be used. So this is about the selection process. So every population after initialization, they have their fitness values, and which is going to have the higher fitness value, those individuals will be taken for the further process. The probability will be high, and we can select them by using some of the methods, that is roulette wheel selection or tournament selection. So by this procedure, we are going to select the individual for the reproduction. Then crossover. Crossover is a genetic operator that combines genetic information from two parent solutions to create a new offspring. The crossover point determines where the genetic material is exchanged between parents. This process introduces diversity in the population and helps explore the new regions of the solution space. Then mutation. Mutation is a genetic operator that introduces random changes in the offspring's genetic material. It helps prevent premature convergence by maintaining genetic diversity in the population. The mutation rate controls the probability of a gene being altered in the offspring. Reproduction. After selection, crossover, mutation, the offspring replaces the least fit individuals in the population. The new population is then evaluated using the fitness function to determine the next generation's quality. This iterative process until a termination condition is met, such as a maximum number of generations. Advantages, which includes doesn't require any derivative information. It is faster and more efficient as compared to a traditional methods. Has a very good parallel capabilities. Optimize both continuous and discrete functions and also multi-objective problems. Provides a list of good solutions and not just a single solution. Disadvantages. Genetic algorithms are not suitable for all problems, especially problems which are simple and for which our derivative information is always available. Fitness value is calculated repeatedly, which might be computationally expensive for some problems. There are no guarantees on the optimality or the quantity of the solution. If start implemented properly, the genetic algorithm may not converge to an optimal solution. Applications. Genetic algorithms are used in various fields, including optimization, machine learning, and computer science. They are applied to problems like scheduling, routing, and machine learning model optimization and game playing. Genetic algorithms can find solutions to complex problems where traditional optimization techniques may struggle. Conclusion. Genetic algorithms are powerful optimization techniques, which are inspired by the principles of natural selection and evolution. By leveraging the selection, crossover, and mutation, genetic algorithms can find high-quality solutions to complex problems. Understanding the key components and parameters of genetic algorithms is essential for designing the effective optimization strategies. Thank you.